Okay. The first one we had to do there was to calculate the value of x. We had in the diagram this point being x and 15, and they told me that OT is 17 units. Okay, so what you guys had to realize is that there is a triangle there, of which they gave you this big angle theta, but we know we're using the reference angle theta. That will be the acute angle that's right there. So when I look at the coordinate given, that 15 is the y value that I have here, and I had to use Pythagoras to find the x value here. So that's just going to be 17 squared minus 15 squared to give me x squared. Because of Pythagoras, I get x to be equal to plus minus 8, and then I must know that it's going to be negative 8 because it's in the negative direction. 5.1.2, I had to calculate tan theta. I'm saying this again, that tan theta is not an angle. It's not you calculating the angle. Tan of theta is a ratio. It's a fraction. It's a numerator over a denominator. And therefore the tan of theta will be the opposite over the adjacent. And that will be 15 over negative 8. Next up was the cos of 180 degrees minus theta. That puts me in the second quadrant, and that's negative cos theta. Cos is adjacent over hypotenuse, and therefore it's going to be negative 8 over 17, which gives me a positive 8 over 17. 5.1.4, they wanted you to find sin squared of theta. So julle graad 8 asseblief stil bly. Sin is going to be opposite over hypotenuse, which is 15 over 17, and it must be squared, and therefore it's going to be 225 over 289. We prefer doing this not in a decimal. Well, not prefer. It shouldn't be in a decimal because they are saying without the use of a calculator. Okay, so the moment that we give decimal answers, it is assumed that you're using a calculator. Alright, the next one they're asking for is the value of A. So we spoke about this yesterday, and it seems like quite a complicated question, but in fact it is not. I have this triangle, of which I know the length of this side is 15, the length of that side is 17, and the length of this one is 8. Then they gave me a coordinate here of P that was given as negative 2 and 8. So in other words, I have another triangle there of which the side is negative 2. These two triangles are similar. That means they're the same shape but different sizes. Now to find out how much this triangle has been enlarged to look like this triangle, it's going to be times 4. Do you agree with me? Because negative 8 divided by 2 will give me 4. And that's how I know that this side will have to be divided by 4 to also get to the actual length in the short triangle. If you were to do it mathematically, you would use the normal similarity functions, where you say negative 2 over negative 8 is equal to A over 15. And then you cross multiply, you get negative 30 equal to negative 8A, and A is going to be equal to 3,75. Any questions about this one? It seemed quite a bit more difficult, but it was not. It's fine. You should still get to 3,75. Yes. With that ratio in similarity, it doesn't really make a difference. Did anyone notice something about 5.2? What did you notice, Babatsu? It was the one in the question paper. Yes. And we also did it in class yesterday. So when I look at that, I hope that you can all recognize this as special angle functions. So the first one I will change to become sin 180 degrees minus 60, cos 180 degrees plus 30, tan 360 minus 45, and then I see that cos 27 is not special. There's nothing I can do with it to make it special. It's just there. Then I go to the denominator. I'm going to say sin, and I notice that 63 and 27 are complementary angles, which means they add up to 90 degrees. The answer of this bracket must still be 63, and that must be an acute angle. Cos 180 degrees. You can also say 180 minus 0. This one is in the second quadrant where sin is positive, so it's sin 60. Times, this is in the third quadrant where cos is negative, negative cos 30. This is fourth quadrant where tan is negative, tan 45. Then I've got the cos 27 degrees over, this one now becomes cos 27 degrees, and the cos of 180, doesn't matter what you do, if you used it as 180 minus 0, you will get minus cos of 0, or you can just continue using it as cos 180. Now you use your special angle, so it's going to be root 3 over 2 times negative root 3 over 2 times negative 1. The cos's cancel out, and this is over negative 1. So that negative and the 1, they all cancel out, and then I'm left with negative 3 over 4.
If here and there, sometimes you write it fast and you forgot to put the little degree thingy at the top, would it be penalized?
Like I did there.
No,
Like I did there. Well, technically you should be, but you won't.
And then the second step, when you're putting everything in brackets, does that have to be there, or can you just go
No,
to
that has to be there.
Has to.
Yeah, because otherwise you can just say that you're using a calculator. Remember, once again, the instructions is without the use of a calculator. Okay, 5.3, prove the identity. Did you notice about this one as well? Right, I get my common denominator. It's cos theta, bracket sin plus 1 plus sin theta. What did I do to this one? Is I have to multiply with 1 plus sin theta. Minus, what did I do to that one? It becomes cos squared theta. Did you guys notice this time the 1 minus cos squared, which makes it sin squared theta plus sin theta over cos theta 1 plus sin theta. Then I take out the sin in common. I'm left with sin theta plus 1 over cos theta bracket 1 plus sin theta. These two things are exactly the same, no? And therefore my answer is going to be equal to tan theta. Who would have gotten 22 out of 22? Good. Good. Okay. Can I page? Ah, you have this identity. We did yesterday, Mons. Okay. Sibyl, I want you to move closer to me. Okay. It's not because you're naughty. I just want to keep an eye on you. Because I'm disappointed in your marks. Not only yours, but I taught you in grade 8. And I don't know. Huh? But we'll sort it out. Okay, the next one you guys had to do was question 5. And that was of 2017. So what we have there is 5.1. Sin 90 degrees minus x times cos 180 degrees plus x plus, ooh, very important, did you notice that? 2 terms. Plus tan x cos x and then sin x minus 180. Do you notice the difference between this one and the one in the previous paper? This is now the one where the angles are variables. So it's not the special angle one. This is in the first quadrant, which makes it positive, but it becomes cos x. This one is in the third quadrant, therefore it becomes negative cos x. Then there's a plus, second term. I've got tan x, cos x, and then this x minus 180. Do you see the problem there? I have to take out a negative first to get it 180 minus x. So it's actually the sin of a negative, which is negative sin. And that's in the second quadrant, which is positive, so it's going to remain negative sin x. Please make sure that you all understand everything up to there. Each term, the sign, and in its simplest form. Any questions? Here I've got a positive times a negative, which becomes negative cos squared x. Here I've got a positive times a negative, so it's minus, and then these three are not the same, they can just stick together, no? But is it okay if I write tan as sin x over cos x? And then all of the others I'm also going to write as fractions, cos x over 1 times sin x over 1. Now this cos and this cos can cancel out. I'm left with negative cos x of cos squared x minus sin square x. Do you notice that this almost looks like an identity? But not yet. And the reason for that is because of the signs. Both should be positive and now both are negative. So I can take out the negative and then I'm left with cos squared x plus sin squared x, which is 1, and my answer is negative 1.
I went and after the first step and took out the cos's in common.
The cos
In common.
in the two terms. And then?
And then I got stuck.
Okay, so you see the problem is we only start doing those things until, do you mean when you get here? Okay. This is now a situation where you have two things that you can do. Either you can take out a cos in common, or you can use your identity. You see the identity. Now, if this was a fraction, I would definitely take out the cos in common so that I can cancel out. But because it's not a fraction, taking something out, it's not really going to help. So, but maybe sometimes that is the way to go, but once you've taken it out and you don't see anything special in the brackets, just go back to the previous step and try something else.
Why is that symbol not a
This one,
no,
this one,
next to in the same
yeah, because I took out a negative because that bracket isn't right. And the sin of a negative is negative. But that's now in the second quadrant, which makes it positive. And the negative times a positive will be a negative. And then it's a positive times a negative, which becomes minus. Okay. Okay, at 5.2 they said sin 315 times tan 210 degrees times sin 190 over cos 100 sin 120. Now I hope that you guys notice that when I look at this, at the expression, I can see I recognize 315 as special. Also tan 210 is special. But 190 is not special. And also 100 is not special either. But then 120 again, it is special. So I'm going to start, get everything in its simplest form. It's going to be sin 360 degrees minus 45. Tan 180 degrees plus 30 degrees. And now this one I'm going to get into its simplest form, sin 180 degrees minus 10. Everyone happy with what I did there? Okay. Now at the bottom, I see that one is going to turn out to be sin 10, which is not special. Just checking out at the bottom if there is something else. Thank you. At the bottom I have to check and see if I can't get another 10 somewhere. And do you notice with 100, I can say it's cos 90 degrees plus 10. And then sin 180 degrees minus 60. Make sure you all understand all of those steps. Now I get to the signs. Sin in the fourth quadrant, negative sin 45. Cos in the third times negative cos 30. That one I can't do anything with it, but it's times negative sin 10. 90 plus is in the second quadrant. That makes cos negative, but now it also changes to sin 10 degrees times sin 60 degrees. Right, a negative times a negative is a positive. Which one did I miss now? Oh, I'm writing cos instead of tan. Excuse me. So it will be positive 10. Excuse me. Okay, so I've got a negative times a negative, which is a positive, divided by a negative, which makes this thing negative. Then you're done with the signs. The sin of 45 is going to be opposite of hypotenuse, which is 1 over root 2. If you used your calculator, it would be root 2 over 2. That's the same thing. Times the tan of 30 is going to be opposite over adjacent, and that gives me 1 over root 3. Am I right? Just check up on me. Or root 3 over 3. And then negative 10 sin 10, and that one it cancels out. And then I've got this over the sin of 60, and the sin of 60 is root 3 over root 2. Over 2. This gives me negative 1 over root 6 times 2 over root 3. With a final answer of negative 2 over root 18. Do you have the same answer? What did I'm now doing without the calculator. Let me just put it in there. 1 over root 2 times 1 over root 3 divided by root 3 over Do you agree with this one here? 1 over root 3, 1 over root 2, sin 45, that's 2 root 2 or 1 over root 2. Tan 30, 3 root 3, that's the same there. Those ones cancel out. Sin 60 is 3 over root 2. Okay, so that gives me 1 over 6, root 6, times, and this one swaps around, it's 2 over root 18. It is right, and then you can just say it is negative 2 over 3 root 2. And negative 2 over 3 root 2 is negative root 2 over 3. You see the implication of doing it with a calculator or without a calculator. So it's just like with the rationalization of the denominator.
So then, I have the same answer, but if when you change
Calculator. You can, yeah.
at the top, I'm getting got the 17 and the 10. I got divided by 80, like cost it.
Yeah, that's fine.
So you can use any.
Then you change that one with a co-function, and you left this one just as a cost, but in its simplest form, 180 minus.
So like, even if you can, if they can combine, if it just
If it's not special, you try to get the two that aren't special to be exactly the same thing. Same function, same angle. But that will probably mean you only have to change one of them. You cannot change both of them. Then the sin will become cos, the cos will become sin. The 10 will become 80, the 80 will become a 10. So you'll be left right from where you started. Okay, so you just change one, and then they will cancel out. But here where I've made the star, you can use the calculator. Okay, you done? Right, so what they've given us here is they say R is a point in the first quadrant, so such that R, a TOR, is alpha. There is R, and this is P. And then this angle, we know there's a big angle beta, but we use the reference angle beta here. So there's a triangle, and there's a triangle. Now they say the sin of alpha is 3 over 5, which means this is 3, this is 5. Do you guys know what this length will be without calculating it even? Y is going to be equal to 4 because of Pythagoras. Okay. Now they're asking you to calculate tan alpha. You see, they're not asking you to calculate alpha because you're not supposed to use a calculator. So the tan of alpha will be opposite over adjacent. That's 3 over 4. The next one, they're asking you to calculate sin of beta. But now we have a problem because we don't have the length of the triangle in that specific triangle. But what they did tell us is that OP is twice the length of OR. Do you agree? Now I know that this one is going to be 10. Everyone agree? Okay, so for me to find the sin of beta, I need the opposite over hypotenuse. Is there anyone that has a plan for me to find the length of that one right there?
No, but you said that because OP is twice the size of OR, that means the rest of the triangle will be also twice the size.
That they will be similar.
Okay.
Yes, yes, that's fine. Good. So because this one is twice the length of that one, I know that this one's length will be twice the length of that one. Therefore, this length will be, is it what? Just a 6. Negative 6. And therefore sin will be negative 6 over 10. And next up they wanted you to find the coordinates of P. Now if you were able to figure out 5.3.2, then finding 5.3.3 will be very easy. Because this one will now be 8. Ne? But not just 8, negative 8. So it's going to be negative 8, negative 6. That's the coordinates of P. Yeah. You can, it will be fine, you will get all the marks for writing just the answer, but you can show the 3 times 2, then you get 6, and then choosing negative 6 because of the coordinate, and then 8, choosing negative 8 because of the coordinate and the position of it. Alright, do you see in this one, we already have one term or one fraction. Let me say it like that. There's already one fraction. So we don't have to find common denominators to make it one fraction. But we do have a problem because of this fraction, and that is that the top has got 2 terms and the bottom has got 2 terms. And that's quite a problem for us because we can't work with it when it's got 2 terms. Who has a plan for me? Where do you think I should start? The first thing, the easiest thing that you notice there that we can do. Change the tan. But now I have to be very careful because I'm going to have fractions inside of a fraction. So I'm saying sin theta over 1 minus sin theta over cos theta times cos squared theta over 1. Over, is there something that you want to change here? Let's just leave it like this first, okay? There is something you can already do, but let's just leave it as it is. And see what happens here. So I see this cos cancels out with one of those coses. So I'm left with sin minus sin theta cos theta. Do you see it's still 2 terms? So I suggest taking out a sin theta, then I'll be left with 1 minus cos theta. Now I just need to try to make the bottom one term. Now look at what I'm going to do. I'm going to say cos theta minus 1 plus, but instead of sin squared theta, I'm going to say 1 minus cos squared theta. Do you understand what I did? Okay. Minus 1 plus 1, it's gone. So I have at the top sin theta 1 minus cos theta. At the bottom at this stage I've got cos theta minus cos squared, plus cos squared theta. Oh, minus cos squared theta. So I can take a cos theta out in common. I'll be left with 1 minus cos theta. Got the same thing at the top and the bottom, they cancel out and my answer is tan theta.
This is where I got stuck. I got the top to be fine, but then I said cos, and I took out the negative to make it 1.
That's fine, but then you will have, you must still end up having cos theta plus cos squared theta. Because you see there's already a negative. So if you take out a negative, it's going to have to become positive. Okay. I want you to do for me. Let me just check. It will be 2016, question 5, from 5.1 up until 5.4. 5.1 up to 5.4. You cannot do 5.5, it's general solution. Sorry. 2016, homework.